Hello and welcome to another Algebra 1 video tutorial. In lesson 11.3 we'll be multiplying a polynomial by a monomial. So the goal will be to apply the distributive property to multiply a polynomial by a monomial using area models to picture the products. So this will be the same as we've multiplied in earlier chapters, so this should be a pretty quick and easy lesson for you since it's not necessarily new for you. Alright, number one, expand the expression 2x times 3x squared y cubed z to the 7th. So this is a monomial times a monomial. And what will we get? Well, we can multiply basically like terms here, or like factors. 2 times 3, that would be 6. X times x squared would be x cubed. And then we cannot combine anything else, so y cubed z to the 7th. All right, number 2. Let's take this monomial negative 3a squared times this trinomial 4a squared b plus 7ab minus 5a cubed b squared. So we use the distributive property here. So we'll distribute over these three here. So it'll be negative 3 times 4. So it'll be negative 12. A squared times a squared is a to the 4th, and then times b. Plus negative 3 times 7. So that'd be negative 21. A squared times a, that'd be a cubed, and times b. Okay, then we're going to get minus a negative, so this is going to be a plus. This is going to be a negative 15 minus negative 15. So we're going to go plus 15. A squared times a cubed would be a to the 5th. And there is not a b there, so it would be b squared. Okay, so that would be monomial times a monomial, and a monomial times a trinomial. But this is no different than what you've done in earlier chapters. All right, expand this expression. 7m cubed times n times the quantity 4m n to the 4th. So another monomial times a monomial. So 7 times 4, that would be 28. M cubed times m would be m to the 4th. N times n to the 4th would be n to the 5th. All right, this monomial 7xy times this trinomial. So we'll go 7 times 2, x times x cubed, and y times y. Minus 7 times 5, x times x, y times y to the 5th, plus 7 times 1, x times x squared, and y times y. And the fifth one here, let's go 1/4 a to the 5th b times this, so that monomial times this trinomial. So we'll go 1/4 of 8, so 8/4 would be 2. A to the 5th times a, so a to the 6th, b times b squared, b cubed. Plus 1/4 of 2, which would be 2/4, so 1/2. A to the 5th times a squared is a to the 7th, and b times basically b to 0, which would just be b. Okay, minus 1/4 of 20, so 20/4 would be 5. A to the 5th times a cubed would be a to the 8th, and b times b would be b squared. All right, part A on this one here. Express the area as the sum of smaller areas. Okay, so we have a rectangle here, and we want the area of this expressed as the sum of the smaller areas. So you can see there's going to be 3 of these blue tiles, 6 of the green tiles. And what are the size of each? Well, we have 3 of the x squared, so we sum those up, we get 3x squared. Plus, these are different sizes here. There are 1x each, and we have 6 of them, so plus 6x. Okay, part B, express the area as the length times the width. So let's say this is the length, this is the width. So this distance across here, the length would be x plus x plus x, so it would be 3x. Times the quantity, this is x plus 2 to 1, so x plus 2. We could have also written it as the quantity x plus 2 times 3x if we considered this the length and this the width. It doesn't matter though. Okay, and then see what equality is shown. Well, they both have to be the same thing. The length times the width would be the same as the sum of the smaller areas. So we can say that 3x times the quantity x plus 2 is equivalent to 3x squared plus 6x. And if we took the time to distribute, 3x times x is 3x squared, and 3 plus 3x times 2 would be 6x. So using the distributive property, we know those are the same. But we could look at them as the sum of the smaller areas, or the area as the length times the width. All right, so let's try one backwards here. Let's draw one first. Draw a rectangle to represent the product 3n times the quantity n plus 5. So what you could do is draw a rectangle first, and just say this is 3n, and this is n plus 5. That would be a way to do it, but let's do it as using the area model with like the algebra tiles, okay? So let's do 3n. So let's say that's n, n, and n, okay? So let's say, try to make these square here, okay? Now, go on the other, so that would be the 3n's. Now the other side is going to be n plus 5. So let's try to make this square if I can. Okay. Okay, so that's n. Now we need 5 1s. So we could put a 5 here, or we could do 5 individual distances of 1. Okay, so I got 1, 2, 3, 4, and 5. Okay, so now extend this all the way across here as best as you can. If I had a straight edge, it would be a little easier. Okay, so now, if I'm just showing the area of each one, this is an n by n, so it's an n squared. These other two are the same. They're n squareds. And then what are the size of these other ones? Well, they're a width of 1 and a length of n, so they're 1 by n. So there are, each of these are n's. Okay, so that leads us to, what's the area expressed as a polynomial? Okay, so if we maybe took the sum of these, so I have 3n squareds, and then how many of these do I have? How many n's do I have? Well, I have 5 rows of 3, so that would be plus 15n. Plus 15n. Or if I took the time to distribute, 3n times n is 3n squared, plus 3n times 5 would be 15n. So you can see how this can be represented a couple different ways using the area model of multiplication. All right, that wraps this up. Your assignment will be 11-3, page 672, number 2 through 30 evens. Thanks for watching, and we'll see you next time.